Welcome to Engineering Scale Models. I am Jason, your host, and I do models. This is going to be video 1 of my electronics series. I'm doing all kinds of cool electronics with your models, your scale models, whether it's a diorama of a streetscape or a tank, aircraft, whatever it be. I'm going to show you how to put some electronics into those models or whatnot. Say for example you have a street scene, you have some traffic lights, and you want the traffic lights to actually run where there's a green, a yellow, and a red, and there's timing in between them, and you can have them cycle. So you have 4 of them for each side of the street. You can actually cycle so cars could actually move and go, and you could actually use motors and cars and magnets to actually drive the cars through when the lights change. And in order to do that, I'll be using an Arduino. This is a Uno, and then under here is a Mega, and these are large microcontrollers, but there are very small ones called Nanos that I will be introducing later in future videos about the microcontroller. But this is just going to be an overview of some of the tools that I am going to be using. Moreover, the measuring equipment to test things and go over some basic components. So, like I said, I'll be going in the overview video. I said I was going to be going through this Make Electronics book by Chris Platt. It's a very good book. It talks about a lot of basic electronics with different things: batteries, LEDs, resistors, how to use a meter, how to measure a resistor, and it talks about all that in here step by step, and we'll be going through that. I'll try to make it simple and down to earth for you guys, but I want to talk about measuring equipment to start out with, and what I'll be using and what I recommend for measuring equipment, because I have a unique perspective on measuring equipment and having good measuring equipment, but also protecting yourself so your measuring equipment doesn't get damaged. So starting from least expensive, this is a meter. It costs about $3 on Amazon. You can also get these like at Harbor Freights. These are very cheap meters, and I only use them for one purpose. I use them to measure amperage, because of the fact that it's unfused, and if it does any damage to the meter, I'm only out $3. So, you know, it's not real bad on cost. If I have my slightly more expensive meter and I run amperage through it, this is fused, so it'll blow my fuse. And again, the fuse is a pain in the butt to change, and the fuse is like $8. So when I measure amperage and circuits, I normally use one of these cheap meters. It'll measure it on 200 nanoamps to microamps to milliamps to 10 regular amps. So, and I use the little clawly leads on there. I leave those on there all the time. So that is this cheap meter. It dial clicks. It will do voltage. It will measure resistors. It's not auto select. It has DC voltage. That's the symbol here is DC. The symbol right here is AC. It's got the sine wave to it. We'll talk more about that in a bit. And then you have your resistance, which is measured by an ohm symbol. This does measure a diode, and it will supposedly measure a transistor, yet I have not tested it. So, and then that would be where you do your NPN or PNP transistors. And we'll cover what all the different components are as we use them. So that is the cheap meter. Like I said, around $3 on Amazon. I have two. I have 2 of them, just because they're cheap, and I believe I got 2 for $6 in a bundle. And then I have my all-purpose go-to meter. This one is about $35, and I like it better than my more expensive meter. This is auto ranging. You turn it on DC and you plug in your leads, and it will, has a huge display, and it will auto range the volts from millivolts to volts, and then it has AC, and then ohms, diodes, and conductivity sound. So if I plug these in, black always goes in the common, and then input is for this, these two are for amperage, and if I touch these two ends it should beep. Yep, it's not on that selected. There it is. See, if it beeps, that means it's a short circuit. So that's one of the features of the meters. This one takes a little bit of time to get used to. I haven't used it in a while, but I get used to it pretty quick, and it does measure amperage, but again, I don't normally use it for amperage. I normally use it for voltage, ohms, diodes, things like that. It'll also do frequencies and things like that. So this is about $35. It's a very good meter. It has a cool stand in the back, if I can get it open. It has a little stand in the back so you can set it up. I plan on setting it up and then having, this camera right there trained on the meter. Try to zoom it in, and then you guys will be able to see what's going on with that. So this meter is about $35, $36 on Amazon, and that's that meter. I also have two of these. I have two of all my meters, and that'll become apparent later in other videos. And this is a meter that was sent to me by alumni. It is a graphical multimeter, and it is interesting. It is a meter along with a oscilloscope. It'll measure your standard voltage down to millivolts, but it will also measure frequencies and amperage and things like this. It is very confusing on how to use it for different functions and things, but like this is like for your ohms, and then you have to select diode, and it's very loud and whatnot. It does supposedly have an auto feature, and it has a stand. So I use this occasionally. When I didn't have an oscilloscope, I used this primarily for a simple oscilloscope, but it's a meter, it works. I will use it occasionally, but it's not as useful as my main meter that I use that was cheaper. These run, from what they told me, about $85 for one of these. And like I said, it is an oscilloscope built in. It's a graphical multimeter, so it does do that, but not as efficiently as an oscilloscope with as many options as an oscilloscope has. And then again, it has your common black, and then it has your standard input for your voltages, capacitors, amperage, or ohms. Then it has your amperage over here, your 10 amp, and then your microamps here. And this is also a fused meter. I would not want to blow a fuse in these, because putting the battery in, the batteries are in here, and the fuse is way in the back, so I believe you would have to disassemble the whole meter to get to the fuse. Now, for the last of measuring equipment, well, not the last, I have one of these. This is a transistor tester. It will test different things. You plug it into the little gates here, and it will tell you what a transistor is, where the different leads are, and whatnot. It'll also tell you if it's still good, but it will also test diodes, inductors, capacitors, and different things like that. You just plug it in, make sure you're in one of the 1, 2, 3s, and don't overlap the 1, 2, 3s. Like, don't put it in 2 1s or 2 2s or 2 3s. you know, if you have 3 legs, 1 and 1, 2, 3, 2 legs like 1 and 2 or 1 and 3, and it will test that for you. So that is a transistor tester. This is a more higher end one. There are some build yourself transistor testers. There's another one that I have that I haven't brought out yet, that I actually like it a little bit better. It's a little less sophisticated. I ended up building it myself and putting a container around it, and it seems to work a smidge better. But you know, this is a out to market, nice looking, nice display and things like that, so it is a decent tester for identifying parts and whatnot. You can also test resistors on it very easily and very quickly. Sometimes when you are building a circuit, you need to test the load that is drawn, or you need to create your own load. And we have these types of units here. This is a load tester. This will draw a certain amount of amperage specifically from a USB port, but it has other inputs here. So this one is specifically for a USB port, and I believe it will draw up to 2.5 amps. I wouldn't want to draw that much because it would overheat pretty quickly, but if you want to test like battery packs, things like that, battery packs and levels, rechargeable batteries, to see if they're still good and how much charge and drain they can take at a time, a load tester is good. If you're testing all kinds of general purpose circuits, I have a larger, more heavy duty with actual wire inputs, a DC jack, 5mm DC jack, along with USB inputs. So this is a very good load tester. It's got a nice cooling fan. It's got a huge transistor on the back, and the fan and aluminum dissipates the heat. This is a very nice load tester. I don't know where I got this from. I believe it was sent to me when I was reviewing some electronics products last year at some point. But this is a very nice load tester right here. So that's on that end. And before I look at the oscilloscopes, I just want to touch base on my work in progress for a multiple bank metering system that I've built. These are cheap little mini meters. This is a pulse wave generator. It generates a pulse wave. This is an electronic load, so similar to what I just showed you. These are power units. I can set the voltage, amperage, and output to a set rate, and deliver that exact amount of voltage and current. I have 2 of those in here, and then these 2 are meters, so I can actually interhook these with these DC jacks. So if I want to run power through the meter so I can monitor the amperage, I can do that, and then I can run out of these banana jacks to my circuit. I can also do things with the pulse wave. I have different ins and outs on this for power, and then I have different switches at the top that control each one. Goes 1, 2, 3, 4, 5, 6. Well, 5, because the pulse wave generator is powered separately. And then in the back is everything all wired up, and this can run on 2 different methods. It can run on a 12-volt battery pack, a 5-volt battery pack, or it can run off my power supply, or I can plug it in with a 12-volt 1 amp 5mm jack power cord, and it will power the whole unit. Running everything, both power units and everything like that, I need 2 amps, but for 1 amp, as long as I'm not putting out more than I'm putting in, you know, that's, you know, Newton's law. You can't have more energy out than that is going in. So, but I normally run it with about 2 amps, and if I run it with my power supply, I can run it at higher than 2 amps. Now let's talk oscilloscopes. This was the very first oscilloscope I got. This is This is a dead battery on this here. Oh, there it goes. So this is a mini oscilloscope. It has dual inputs and a square wave output. It is very compact and very cute, and it is very cheap. Doesn't cost very much, and it's very simple software. You know, you can stand it up. Does do what it needs to do, but I grew out of it needing to test multiple 555 timer circuits and adjusting different things, so seeing it was very nice to send me this last year. I never got to do a proper review on it, but I will be doing one in the future. This is a 4-channel oscilloscope. It is very nice. I don't have it plugged in at the moment because I haven't found a location for it yet, but this is a very nice oscilloscope, and it will be set up in the future, and I will show you what a lead looks like for this. Looks like this right here. It has your ground and then the line hook that you want to test. There's also different types of probes. You can, the jabby pointy probe and things like that to gauge it, but this will test if there's a sine wave, a pulse wave, a sawtooth wave, different things like that. And then that is probably the nicest piece of electronic equipment I have, is that oscilloscope. I am very happy to have that, and it is very useful, and we will go into that when it's time, and I show you different waves and pulses that are coming from the microcircuits and things like that. So that is an overview of the measuring equipment and tools that I'll be using. I don't have my power supply out yet. It's still packed away. I'm working on getting that set up, but I'll have that set up in hopefully for the next part 2, or the next video, part 2 in this series, where I'll start going over some components and different things like that. We'll talk about LEDs, resistors, capacitors, inductors, and all that good stuff. I'll show you what they look like in a schematic on the drawing pad, and then I'll talk more about the microcontrollers and what they can do, and maybe a little test demo. So that is an overview of the measuring equipment, tools in general, wire strippers, pliers, flat nose pliers. It all depends on what you're doing. If you're just working with the Dreno kits, you know, they have wires that have leads on them that plug in, so you really don't need wire. You really don't have to strip wire and all that stuff. If you buy like the kits of Adrenos that come with different parts like potentiometers and things like that, it normally comes with everything you need to build circuits and test them. But to build complete circuits, like I said at the beginning with the street light thing, you're going to need surface mount LEDs. They're going to be tricky to solder, so you're going to need a soldering iron. Like I have this one here. This company makes some of my favorite soldering irons. I do not know the name of it offhand. I'll have to remember what it is, but they make this one, and they make another one that runs off USB-C, and it is fantastic. This one's fantastic. So you're gonna have to, soldering surface mount LEDs is kind of tricky, and then running lines to each of the anodes for the signal, so you can have them all timed, and then common grounding the rest, and then the resistors and all that stuff. So I'm going to talk about how to do all that with wiring, and hopefully I can show you how to put it through a hollow plastic styrene tube, and mount it on a custom made circuit board and things like that. That's all stuff I plan on getting into the video. Also plan on talking about servos for moving turrets on tanks, spinning propellers. You can get some pretty tiny servo motors, or even motors in general, and you could spin your propeller blades, different things like that. And that's all things you can control with a microcontroller. Landing lights, and this is things I want to teach you guys how to do, so you can add those to your models, do all kinds of crazy stuff and make them look awesome. But I'm going to call it on this video here about 20 minutes. The video links are going to run varied on what I'm teaching today. I just wanted to give you guys an overview of the measurement equipment and different things like that. And that's going to be it. Here are my links to social media, and also you can visit me on Patreon, suggest ideas, support the channel. You don't have to sign up to leave me messages there or whatnot. You can just contact me there. You don't have to sign up or anything. Signing up is appreciated. But thank you guys very much, and I hope